So I did want to take a brief foray into discussing simple harmonic motion. Um, so harmonic motion is a repetitive motion, and simple harmonic means that the repetition is exactly the same every single time. So this would be like a wheel spinning, a spring going back and forth, a pendulum swinging back and forth. That type of thing would be harmonic motion. And if it's exactly the same, especially the wheel turning, is a great example of simple harmonic motion. The general idea of motion is not going to change. Velocity is still the derivative of displacement. Acceleration is still the derivative of velocity. Jerk is still the derivative of acceleration. The description is going to change a little bit. Just because it's repetitive motion, it doesn't make sense to always say it's going right at this time, left at this time, right at this time, left at this time, right at this time, left at this time, if it's going to be the same every time. So we tend to say, okay, what values is the particle moving between and what's the period? And then within one period, when does it speed up or slow down? And that aspect usually requires a calculator, although the example I'm going to use, I'm going to do it without the calculator. So with this, a particle's displacement is represented by s of t equals 5 cosine t. I want to figure out velocity, acceleration, jerk, what values is the particle moving between, what's the period of its motion, and when does it speed up, slow down in the interval 0 to 2 pi. So velocity is the derivative of displacement, so that would be -5 sine of t. Acceleration is the derivative of that, which would be -5 cosine of t. And jerk is the derivative of that, which would be 5 sine of t. And actually, if you notice, if I go one further, I get back to where I started, and that the derivative of jerk would be 5 cosine of t. I'm sure there's a name for the derivative of jerk. I just don't know it. But mathematically, I end up back at displacement, even though it wouldn't actually be displacement. So in terms of what values the particle is moving between, this is where kind of knowledge of my trig functions is very helpful. So moving between would be represented by my displacement. So looking at my displacement, I know that cosine is always between the values of -1 and, sorry, I can write more neatly than that, between -1 and 1. Well, if I go ahead and multiply all of that by 5, I get that 5 cosine of t will always be between -5 and +5. In terms of the period of its motion, again, I can focus on the cosine of t. I know that sine and cosine both have a period of 2 pi, and I've not multiplied anything on the inside of cosine to change the period, because it's multiplying t on the inside that would change the period. So my period is still 2 pi. So when I'm being given the interval 0 to 2 pi, I'm being asked when does it speed up and slow down in the interval 0 to 2 pi. So I'm going to approach this like I did with linear motion. I'm going to make a sign chart of my time from 0 to 2 pi. If I focus on just velocity, velocity is -5 sine of t. Well, the velocity would be 0 at pi. It is also at 0 and 2 pi, but those are already on my number line. From 0 to pi, velocity, whoops, apologies. Having issues today. From 0 to pi, that's quadrants 1 and 2 of the unit circle. So sine would be positive in quadrants 1 and 2. But I'm multiplying that positive sign by a -5, so velocity is going to be negative there. From pi to 2 pi, that's quadrants 3 and 4. Sine is negative, but I'm multiplying that by a -5, so I get positive velocities. Well, then I need my acceleration. Acceleration is -5 cosine of t. Cosine is 0 at pi over 2 and 3 pi over 2. Well, from 0 to pi over 2, that's quadrant 1. Cosine is positive, but I'm multiplying by a negative 5. So my acceleration will be negative. From pi over 2 to pi, that's quadrant 2. Cosine is negative, but multiplying that by a negative 5 gives me a positive acceleration. From pi to 3 pi over 2, that's quadrant 3. Cosine's still negative, but I'm still multiplying by negative 5 to get a positive acceleration. And 3 pi over 2 to 2 pi, that's quadrant 4. Cosine would be positive, but I'm multiplying by a negative 5 to get a negative acceleration. So now I can see, okay, we're going to speed up from 0 to 2 pi, or to pi over 2, sorry, because velocity and acceleration have the same sign. Slow down from pi over 2 to pi. Oops. Come on. Because velocity and acceleration have different signs. Speed up from pi to 3 pi over 2, because velocity and acceleration have the same sign, and then slow down from 3 pi over 2 to 2 pi, because velocity and acceleration have different signs.